Hi everyone, welcome back to the Comptia Network Plus course. In addition to trace route and trace search, you can use path ping, which is a lot like trace route. So you can see here, see users Todd Lamel, path ping lamel.com, trace route lamel.com, 184.172.53.52 over a maximum of 30 hops. So you can see here it's gone to 192.168.147.192.168.133.2. Computing statistics 25 seconds. Hop RTT lost sent PCT lost sent equals PCT address WINQI14QVT D8DHOG local domain 192.168.133.147 and trace route 192.168.133.2 trace complete. Okay, using ipconfig and ifconfig. The utilities known as ipconfig in Windows and ifconfig in Unix, Linux and Mac will display the current configuration of TCP/IP on a given workstation, including the current IP address, DNS configuration, Windows Internet Naming Services WINS configuration, and default gateway. In the following sections I will show you how to use both. Using the ipconfig utility with the new Mac, Windows 10 and Windows Server 2016 operating systems. You can now see the IPv6 configuration because IPv6 is enabled by default. The output of the ipconfig command provides the basic routed protocol information on your machine. From a DOS prompt, type ipconfig and you'll see something like this. So here's the output you'll see from typing ipconfig. There sure are a lot of options in this output compared to the output of earlier versions of Windows. First, what's up with all these interfaces showing I have only two? So I'll just show you there again. I have only two, one Ethernet and one wireless. You can see that my Ethernet adapter shows up first and has an IP address, mask, a default gateway plus an IPv6 address and a DNS suffix. The next configured interface is the wireless local area network LAN adapter, which has an IP address, a mask, a default gateway, an IP version 6 address and the IPv6 default gateway as well. This IPv6 default gateway address is simply my router advertising that it runs IPv6 and saying I am the way out of the local LAN. The next adapters are disconnected because they are logical interfaces and I'm not using them. My machine actually shows 8, but I cut the output because it provides no new information. They're automatically inserted because IPv6 is installed and running on my machine, and these adapters allow me to run IPv6 over an IPv4 only network. But just in case the ipconfig command doesn't provide enough information, you can try ipconfig/all. Talk about details. Here's the beginning of that output. So here's the output from the ip/config all command. And here it is again. As you can see, it's more of the same, a whole lot more. The most important thing I want you to notice is that I received the hardware information about each interface, including the media access control MAC address. Also significant is that I can see the dynamic host configuration protocol DHCP lease times and DNS addresses now. But why stop there? There are two more valuable options you need to use with the ipconfig command. They are release and renew. When you change networks, you get the IP address of that subnet and or virtual LAN, VLAN. Windows 10 makes most of the time without doing anything, but sometimes I do have to renew the IP configuration when changing networks, but that's just easy. Type ipconfig renew from the command prompt, and if you're connected to a DHCP server that's available, you'll then magically receive an IP address. Now if that still doesn't work, you need to release and renew your IP settings. To release your current DHCP TCP IP information, you want to evaluate your command prompt, or you'll get the following warning: C uses TAML ipconfig release. The request operation requires elevation. C users TAML. Should this happen, choose Start All Programs, Accessories, command prompt, right click and choose Run as Administrator. Or of course you'll have to enter your name and password to do this if you're using Windows 7 or 10, but we love Windows 7 and 10, right? Okay, maybe not always. Figure 7.14 shows how I did this. Once your command prompt has been duly elevated, you can use the ipconfig /release command and then the ipconfig /renew command to get a new TCP IP information for your host, using the ifconfig utility. There is a utility in Linux, Unix, Mac that will give you information similar to what ipconfig shows. It's called ifconfig, short for interface configuration. Although ipconfig and ifconfig show similar information, there are major differences between these two utilities. The config utility is mainly used to view the TCP IP configuration for a computer. You can use the ifconfig to do the same thing, but ifconfig can also be used to configure a protocol or a particular network interface. The general syntax of the ifconfig command is as follows: interface address parameters. The interface parameters equals the Unix name of the interface, such as ETH0. If the optional address parameter is specified, the ifconfig command sets the IP address for the interface to the address you've specified. When the ifconfig command is used by itself with no parameters, all configured interfaces will be reported on. But if only one interface name is specified, you'll get output that looks like this. So here you can see what the output from the ifconfig command. Sorry, now the machine was a bit slow there. So looking at this, you can see that the ETH0 interface is a 10 megabits per second in Ethernet interface. The interface's MAC and IP address information is displayed in this output as well, and although not shown in the output, the ifconfig tool can show you the DNS information configured on the host using the iptables utility. The iptables firewall utility is built for the Linux operating system. It is a command line utility that uses what's called chains to allow or disallow traffic. When traffic arrives, iptables look for a rule that addresses that traffic type, and if none exists, it will enforce the default rule. There are 3 different chain types. Input controls behavior for incoming connections. Forward, used for incoming connections that aren't being delivered locally, like our router would receive. Output, used for outgoing connections. You can set the default action to accept, drop or reject, with the difference between reject and drop being that rejected that reject sends an error message back to the source. So here's what the IP tables looks like using the ping utility. The ping utility is the most basic TCP IP utility. It's included with most TCP IP stacks for most platforms. Windows again is no exception. In most cases, ping is a command line utility, although there are many GUI implementations available. You can use the ping utility for two primary purposes: to find out if a host is responding, to find out if you can reach a host. Here's the syntax. Here's the syntax. You can use either ping hostname or ping IP address. If you ping any station that has an IP address, the ICMP that's part of that particular host's TCP IP stack will respond to the request. The ICMP test and response looks something like this. So you can see here ping 2.04.153.163.2 pinging 204.153.163.2 with 32 bytes of data, and you can see here we received a reply from 204.153.163.2. Because I received a reply from the destination 204.153.163.2 in this case, I know that I can reach the host and that it's responding to basic requests. Don't forget that you can use name resolution and ping to name, such as www.cibex.com. As long as the name can be resolved, you're golden. Most versions of ping work the same way, but there are some switches you can use to specify certain information, like the number of packets to send, how big is a packet to send, and so on. And if you're running the Windows command line version of ping, just use the question mark or minus question mark switch to display a list of available options like this. As you can see here, see users terminal ping, and here is a table of the ping switch. So I won't go through all this, I'll just scroll down through it slowly so you can read it there. As you can see, there's a plethora of options that you can use with the ping command from a DOS prompt, but I really want you to focus on a few from the previous output. I'm going to go over only a few of them, but you can get on your host machine and play with all options. The -A switch is a very cool, because if you have a name resolution such as a DNS server, you can see the name of the destination host even if you only know its IP address. The -N switch sets the number of echo requests to send, where 4 is the default, and the -W switch allows you to adjust the timeout in milliseconds. The default ping is 1 second, 1000 ms. The -6 is also nice if you want to ping an IPv6 host. By the way, unless you really love typing a 128-bit address, this is a wonderful example of how important name resolution is. And then there's -T, which keeps the ping running. Here's an example of a ping to an IP version 6 address. From the MAC address, you can use the ping command. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.